All right. Hi, folks. Hi, Anthony. It's been a little bit. I hope everybody had a good holiday. I need to get back to this a little bit. I have maybe an hour or two to work on it. I'd like to work on specifically this uh, loopback area next to the pumpkin. I also did do a little bit of work on the pumpkin itself, which kind of reflects here, but I have an actual mech that I want to kind of put in this now. But yeah, those are really my goals for today. Get this defined, put the pumpkin in, and then if there's any time left, work a little bit more on this right side. All right, there's a couple things I gotta do immediately though. So if you hang on 1 second. There we go. Okay. Let's see. The pumpkin mech. I did a little bit of work on the pumpkin mech actually. I need to have too many things shown. There we go. I did a little bit of work on the pumpkin mech. So I can drag that in here and show you kind of what I did. I took the pumpkin, I defined him a little bit more, and I started breaking things up into a couple different pieces. So here's this animation or the assembly file here. If you take a quick look at this guy, I've got the platform down here. Yes, he's floating a little bit. There's going to be some brackets and things that's going to hold him up. I have holes for his eyebrows because I'd like his eyebrows to kind of articulate so he can kind of do expressions. And I have him hollowed out with some mounting points and things. But then this thing here, uh, isolate. This thing here is a an LED uh, panel. So each eye would is going to have four different positions. So he can look straight at you. He can look to the left. He can look to the right, and he can look kind of up. So up, left, right, and straight. And then the mouth is built out of 7 LEDs. That way, I can kind of make him do like horizontal mouth motions. So when he's speaking, it kind of goes wong 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 type of thing. Um, the mouth will be diffused, so it'll look like just one line. But the eyes obviously won't be diffused, so they'll have a nice hot spot where he's actually looking. And if you look at this in here, so you can see the mouth LEDs all kind of line up right in the mouth. The eyes, the straight on eye is perfectly centered on this thing, but the left, right, and up eyes are slightly cut off on the little triangle to make it look like he's looking in that direction and his pupils are kind of offset a little bit. And because of how small the LEDs kind of are, and from the distance that you're looking at, if I had just the full LED kind of shifted to the left, you wouldn't really tell that he's looking to the left per se, but because the LED will be partly cut off, you'll be able to see, oh, the LED kind of shifted one way or the other, kind of, or at least that's what my hope is. So yeah, that's for the mouth because originally I was gonna have the mouth kind of open up and up and down, kind of like what you call it, the skull in No Fear, but things are getting really tight where the pumpkin is, and I'd rather have the pumpkin shift left and right and have the eyes look left and right than have to worry about the whole mouth assembly. And this pumpkin right now is planned on having, well, all right, so here's the thing with the eyes. It looks like I need 8 LEDs for the eyes, which I need 8 physical LEDs for the eyes, but I only need 4 LED indices for the eyes. your eyes very rare. Like, there's no reason why you would ever really want the pumpkin to go cross-eyed or look weirdly in the other way, or have one eye down, one eye up, or something like that. At least I can't foresee any reason why you'd want to do that. Yeah, it would look silly, but that's not. It wouldn't really make sense in a lot of cases to waste four indices just to have one silly pose every once in a while. So what's really going to happen is the center pupil on both sides are both going to be, say, index 5. And then the left will be index 6, the right will be index 7, and the top will be index 8. So they're all going to be shared indices. And it'll just kind of split the LED line across the two. And then off of one of these eyes, it'll go down to the mouth, where the mouth is going to be, index 0 through 7, or 0 through 6, whatever that offset's going to be, right? So 7, 8, 9, 10, 11. There's only going to be 11 indices used for this head, plus some other indices used for like lighting around the pumpkin, because I do want to have some LEDs around him, which is one of the reasons I left him floating up, so I could potentially add some spacings and things to lift him up and allow wires to come out and loop around for LEDs, or LED boards to stick out from the bottom. Yeah, I want some lighting around him for foliage in the back and other like rim lighting and things as he's talking. So, assuming I use, or assuming I put an entire 16 in, or I guess it's 32 LEDs per line with fast boards. If I use 16 LEDs on this guy, then that'll be great. That'll be 11 for the face, and that'll leave another 5 or 6, or however I plan on putting for all the scenery around him. Anyways, so the idea is still to have him look like rotate left and right. His eyes can move left and right and up, and his mouth can talk. The only thing that changes, he's not going to have an opening mouth, and I think that's going to be okay. Oh, and his eyebrows will go, up, down, whatever, with a couple servos in here that will get mounted back in here somehow. And I might need to make this opening a little bit bigger to support all of the little servo armatures and a human hand to get in there to like fiddle and connect things. I'll know when I 3D print this thing. It will fit in my 3D printer. This pumpkin head will, in fact, fit in my 3D printer. It just barely fits in my 3D printer, but it fits, and it'll take about 25 hours to print the thing. But it'll work. Anyways, let's get him installed. Let's see, how far up is it? Actually, I can just deal with that later. So I'll take that. I'll get rid of that. I'll mate this into here. And I will offset this with the bottom. I really kind of want the minimal offset of this thing. Because I really don't want him to be too high up. I want him to be nice and nestled in there, ideally. All right, so what you're seeing right now is a little bit of a conflict with this spinner. This left spinner, one of the reasons I want to deal with this whole thing is this spinner is now not going to be its own separate assembly. It's going to be an assembly that's a part of the left guide here. That way I can take these opto switches, I can move them to the left side, and the spinner can still fit, and then that'll give me more space over here in this corner. Yeah, so I can give them so I can have more space in this corner, because this spinner will spin fine like right here, but with the pumpkin there, the whole opto assembly is not going to be a good thing. So if I can move the optos on the left, which I have plenty of space here on the left for optos and everything, poke a little hole for the wire to go down. then this will be completely empty. It'll have this little section over here, which is 100% fine for this pumpkin. So I don't need the pumpkin to be shifted too far over. In fact, I can probably shift the pumpkin back a little bit, which would be better for the ramp, to be quite frank. Um, and even, no, in fact, I can pull the pumpkin forward more, which would be even better for the ramp. Because I do kind of want the pumpkin to hover over these targets a little bit, but I can't do that now because the spinner's kind of in the way. So you see like a little bit of manipulation I'm doing. So anyways, I'm gonna leave the pumpkin at that height for now, 1 1/4, because that's just kind of above the plastic. And straight down. And when the pumpkin is set, he's actually, no, stop that. He's actually gonna be rotated slightly this way. This is front facing out this way more, kind of diagonal. That way he's looking more at you, slightly diagonal. So that's good. All right, so that was step one of what I wanted to do. Step two is the left bracket. Well, actually, I'm going to do the right bracket first because the right bracket isn't going to have the spinner attached to it. And that's the more complex one, and that'll also dictate more where the pumpkin needs to go. Then the left one is a little complex because basically I'm going to take the spinner, I'm going to duplicate the spinner, whatchamacallit, part, this metal bracket part, flip it, and then turn that into the guide. I think maybe, or maybe I won't. Maybe I'll just. I mean, the measurements are pretty simple, so maybe I won't. But then I need to deal with these flanges, so I'll figure that out when the time comes. But I'm going to first start with this rail. I guess instead of just mucking around and saying I should do this, I'll actually create the part. Pumpkin. Oh, the pumpkin goes into devices. Let me clean this up for a second. Plastic inlay. Oh, these are all the in posts, double post rings. Right. Oh, not rotate. Not rotate. So plastic post, plastic post. Yeah, okay, so plastic posts go into posts, plastic rectangle targets go into targets. Down post, down post. Solid, yeah, okay. Down posts go into devices. Plastic post double ring goes into post plastic. Upper left slingshot. Oh, that's the rubber. This is. Oh, yeah, these are rubbers. So these should go into rubber. New folder. Rubbers. Linear slingshot is a device. Washer. Black rubber post. What is this? Where's this? In somewhere. Oh, that post. Yeah, that needs to go into posts metal. Double ring goes into post plastic. Straight edge ramp. I'm still working on that. Opto spinner is going to be removed. The wire guide can live there for now. Flat washer. What the hell is a flat washer here? Where's that flat washer? Oh, it's the washer underneath that post. No, I'm sorry. It's the wash. It's the washer in between, right there. Right. Flat washer. This should go in. Do I have hardware? No. New folder. Hardware. Not hardware. Hardware. Hi, Anthony. Or Andrew. Yeah. Yeah. You're my first opponent, isn't it? Yeah, it's Rhode Island State Finals today, which is one of the things I need to go and do later on. For plastic ramp. Yeah, yeah, okay. All right, now that that's done, now I can add a new insert component, new part. This is going to be a metal guide. Guide. Spinner loop right. Or yeah, yeah, it should be fun. Yeah, I'm excited to see what happens. Hmm. Where's my part? Origin. I'm sorry. Pop mate with top. Mate with top. And then the position of this thing needs to move over to, oh, that's not what I wanted to do. Move you over to there-ish. All right, let's edit this duder. It's got to be this guide here. Oh, whoops. Uh, Create a sketch. Now I can convert these entities and do the same mumbo jumbo that I have been for a while. Okay, so and I am going to need to adjust this because this obviously is going into the target, which is not what I want. I want it to go a little above the target. But to start, I can uh, convert the entities. Then I will unassociate all of them because that's how I roll. And all of these should have decent positions. Actually, I don't want to fix. I don't want that. I want to fix this. Um, this is, yeah. All right, and now I will. Instead of this being 3 point whatever the hell that is, it's going to be 2 and 7/8. I think. No, 2 and 3/4. 2 and 3/4. Nope. So the reason why it can't be 2 and 3/4 here is the target won't have any flex on this left side because this metal is going to come out a little bit more to the left. So this really needs to be 2 and 5/8. Now the target has flex point for the ball to hit it. Okay. So that's that. Let's isolate and make. Uh, Okay, so I'm gonna make or I'm gonna start the sweep on this upper left hand point here because that point is unlikely to move because it's all mated with orbits and things, and I'm still kind of mucking around with this lower section here where the targets are. Because once I have that extra space when I move the spinner to the other bracket, uh, I can readjust the pumpkin. I might be able to readjust the targets and just tighten things up a little bit more. So I want this to be kind of flex space, so to speak. So I'll start with this. Oh no, come on. This. We'll make plane on there. Wow, you really that's just not rotating the way I want it to. All right, we'll do that. This is going to be 1 1/8 tall and 1/16 deep. 16. And then sweep. Okay. What is this sketch down here? Why is this thing? Better. All right. So we have a post over here, which I think that's why I made it 5/8 because right here is the half-inch mark that can go next to the post. I'm gonna have a mount point here. This is gonna be kind of a slam point, so I'm gonna double that right there. And this can be a single point right over here because that the ball isn't gonna slam there as much as it's gonna slam back here. At least that's what I suspect. So let's go to the bottom. And there's going to be a little bit of touchy feely with this because there are other guides that need to be taken into consideration over here. Already perpendicular. That needs to be perpendicular. And then over here, I said this was going to be a double mount point, which is 1 inch. And then down here is going to be a single mount point, which is 1/2 inch, approximately. All right, so all of these edges should be equal. And they're going to be 0.5 inches. The distance from here to here will be, yeah, probably 1/8 is fine. And this length needs to be 1 inch. Yeah, so you can see even with just a single point here, like a mount point there, this isn't gonna flex around much. So between this and these 2 points, when you slam the ball into the thing, it's not gonna go anywhere. It really ain't. All right, and now we oh, we will create the holes for all center points. And they are um can't remember what I use for these. 0.2? Is it 0.2 that I use? I know it's not a quarter of an inch. I think it's 0.2. I'll say 0.2 for now. Rude. This way. 16. bottom, trim out all this other excess. That one horizontal. I don't want this horizontal. This perpendicular. And this other one down here is not horizontal, correct? Nope, this other one is horizontal too, because fuck you, that's why. Alright. That's why we zoom in and check, everybody. That is why we zoom in and check. These arcs can just be converted entities. No, convert entity. Convert both entities, please. Okay. Are you not? Or did you? Really? Ow. Convert, and thank you. This needs to be perpendicular. Oh, perpendicular. These two pieces, please. There we go. All right. Sketch features cut. 1/8. Fillet 132 is the inside fillets. Kaboom, kaboom, kaboom. And then fillet 332 is the outside fillets. And then that'll convert to sheet metal. No, not that. Nice and cleanly. SolidWorks won't complain. And finally, a chamfer of 1/8 on all corners, as usual. Where's my corner? There. Okay, so now let's see if this actually fits. And oh man, it just barely fits right there. Oh man. So I got a couple options with this. Option one, obviously this left side is effectively fine. It's effectively fine because this actually is perfectly fine. It's right below where the little nut part is, the hex section is with this, so that fits fine there. Just barely, but it fits. This is a little tight. Now the nice thing about this is I can actually adjust this particular mounting point on this rail. I got plenty of space on this rail to do that. And if there's going to be any banging on like this section here, all it's going to do is go into the rubber, so it's not really going to affect anything. It doesn't change trajectories. It's just kind of a guide. So ultimately, this little point down here doesn't matter. So I'm going to take this and move it up because this right here does matter because that's what loops this thing around. So if this gets out of whack for one reason or another, bad things can happen. Or bad returns can happen, and it can rattle and not be great to go to this upper shot area. So, all right, let's go into this component. And so this boss extrude, instead of it being 5/8, it can be 3/4. That moves it out of the way, and now we're perfectly fine. And because everything's associated, that changed that dimple. So now this is all good. One thing I don't like is how far down this is, because this is a little further out of the way from the rubber than I like. So I am going to change this arc a little bit. I'm going to bump it up ever so slightly, like just is probably only a 32nd of an inch or less, just to snug that up a little bit more. Kind of like how this one is. These rubbers are close enough for what I want them to be, but there might be a little bit of extra slop, so I don't want this super tight. But if there's a little, well, maybe that doesn't matter. No, I'm not going to do it. Yeah, I've convinced myself not to do it. All right, now let's look down here. In this section here, if we hide this for a second, we can see, because that's still where the spinner is going to roughly go. So this attaches to wood perfectly fine right there. And in fact, it can probably, instead of being an eighth, it can be a 16th. Because if that goes straight, actually, it might, I'll leave it as an eighth. I mean, there's nothing wrong with that. That leaves some separation around. So yeah, no, this looks good. This looks good. Okay, so that's one guide done. Now this guide needs to get saved external to the assembly. Was metal guides. Okay, so that's external to the assembly. Now is this left side. This left side is going to be a little more difficult for two reasons. Let's change this view to be this. All right, this is going to be a little more difficult for two reasons. Reason one is this is a fairly sharp point, right? So I can't just have a pad here and a pad here. The pad needs to be down here and up here. Obviously, the pad needs to be on this side, on the entry point, because it's going to be slamming into things, which we don't want stuff to get mangled when the ball slams. And this is absolutely going to be a slam point because it's going to reflect the ball and fairly often. You can see this example of the ball down here where it's hitting on this left side, ricocheting over to here, and then looping around. So if the ball hits right here and ricochets over, it will also. So there needs to be a pad here. There needs to be a pad here. A double pad on this side, actually. A single pad right here. So it's going to be the reverse of this. This had a single and a double. This is going to be a double and a single because of where the ball would slam. And that's also going to affect this guide here because this guide is probably going to have to pull out a little bit more to allow for the size of this pad. Then I'm going to have a single pad over here. And to denote where this arc is, I might just have a little down foot, but it depends because I need to make sure that this pad extends out. It's gonna get a little hairy trying to model this thing just because of what it is. And then when I actually need to bend it, it's going to be a little difficult because of how things need to go. And so another option, which might be the better option, if I do a double pad down here, or if I do a single pad here, a double pad here, and then that double pad goes into an in-cut into the wood. If you remember over on like these side rails and things, I made these little wood in-cuts like this to make sure the guides stay where they need to stay, right? Like this goes down into the playfield a little bit. So if I do something like that over here, come on, like right along here, I have an in-cut for there. Then I don't need a pad that kind of sticks straight out. It'll still add rigidity so the thing can't really bend and flex out of the way. I can add a pad here. I can add it, and I can still add my double pad. Maybe that's the correct thing to do. It'll be a lot easier to model and bend that thing because I won't have things kind of folding underneath each other. And then again, this section over here just needs one like, little exit pad. I'm gonna give that a try. I think I'm gonna give that a try. Once that section's in place, I can then worry about the spinner thing, right? The spinner part, which is gonna be complex in and of itself because really this spinner, I mean, technically it should be attached on this right side because it's a little more parallel to the right side than it is the left side. So I'm not fully sure like how some of this is gonna how well some of this is gonna work. Yeah, it's gonna get a little actually if the yeah. So here's the other thing. The spinner technically is gonna move over, not like that. Spinner is technically gonna move over. Can I move the spinner? Oh, I have him fixed. Uh, really? Oh, that's just the spinner. No, that's both parts. Why can't I make it float? Am I blind? Wait, what? Why is the opto spinner added to the right inlane ramp? What? Wait, what? What? Wait a minute, what's going on? Oh, the bloody spinner got no. Pull. Yes. What the hell? Okay. Well, now I can float. Somehow the spinner got added into the ramp assembly. Is not what I want. This is why it's important to have directories or folders set up so you don't accidentally drag things around. So yeah, you can see the like the difference in shape. So if I rotate this down more, it's going to be more in line with, it might work all right because I can put it in diagonal like that, but it won't look like a flat wall that you're hitting into, so it'll be definitely a little different. And the spinner needs, well, I guess, oh no, because the spinner would be over here more because of where that ramp is. Yeah, so it might get interesting. Um, I might need to just make a reversed bracket of this kind of for over here. Ugh. All right. Well, anyways, I'll let me deal with that later. First things first is to do the guide. So let's create a new part and do the left spinner guide. This is mental guide spinner move left. Be mated onto the top of the playfield. And then the origin gets moved kind of over to there-ish. Okay. Actually, before I forget, let's save this in an external file. Okay. And now let's edit it. So this guy needs the guide itself. If I do things correctly, it needs the guide. Convert entities. This and this. Now, this outer loop, the right side loop, I designed it so uh, the guide curve was on the outside. In this case, I'm designing it so the guide curve is on the inside when I make my sweep, because that's what I expect the ball to hit. Whereas this, I expected the ball to hit on the outside. And I even kind of designed it like that with where the ball is right here. I expected it to be slightly on the outside. Okay. Now let's unassociate and do the thing that we typically do. One eighth. Oh. This is 2.5. 2.5 won't work. So 2 and 9 are 7/16. Yeah, that'll work. Now, why is this arc not okay? Something not tangent. Tangent. Oh, I need to fix this. There we go. Okay, so for this one, again, I'm going to do the exit on this. I don't really know how the entrance is going to get adjusted, because I might need to change the bend, like this bend here, and arc this in more or pull it out more when once I make the actual thing. So I will choose this point. Well, actually, first I'm going to isolate the thing. Then I'll choose this point. Oh, no, then I will edit the thing. Now I'll choose this point and make a plane off of that. And again, as I said, it needs to be on the inside this time. Hey, look, it actually rotated properly. One eighth. 16. And sweep. All right. Now comes the difficult questions. On the bottom. All right, on this side, I know I want a double, or I'm pretty sure I said I wanted a double here because that's going to be a slam point. So I can go ahead and just draw that. And then I said I wanted a single potentially up here, somewhere. All right, so now let's make these things have some real value so I can actually see what my space is going to be like. Oof. Oof. I don't have any space at all. Okay. Oof. Oof. I don't. All right, you know what? I don't even think I need a footprint over here now that I'm seeing what the size actually is in spacings. Um, 1/8. Now that I'm actually seeing this, yeah, I don't even think I need a. So if I get rid of this altogether and I just put it on this side, it makes more sense. And then I can just have an in cut right along here to help keep that guide in place. I think that'll make more sense, and I think that'll be easier to model this thing. And this are equal to this. Yeah. Yeah, I think that's what I'm going to do. Because of how small this thing is. This is not going to get bent out of shape too much if I just put a, yeah, that'll be fine. So there's that. I need to make the holes. Oh yeah, and then I'm gonna have to go back and make sure the holes are all the right size because, like I said, I didn't remember what my hole size is. It's been a hot minute since I've been working on this. Right now I'm setting it to 0.2. Like that. Extrude 1/16. Sketch. Comes the fun part. Why do you always do that? Stop. Ugh. All right, so over here, we may be there-ish. And then it's going to go all the way to this. So I know exactly where my bends are. So in this case, I want to convert entities, this and this. This is going to be a horizontal here. Thank you for not associating properly. Again. And this goes to here, across to here, comes down. Here, 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 and here. All right, so the real distance between this and this is not going to be 1 inch. It's going to be half an inch, 5/8 of an inch, like that. So that's going to cut in. And then I'm going to do half an inch in cut. Or no, I'm going to do a 3/8 inch in cut, and that'll add the rigidity here, make sure it goes in the right spot when I do the thing. Yes. Okay. One eighth. What the hell do you mean the sketch is not good? Oh, because it. Where the fuck did that line go? Didn't I make that line? Maybe not. All right. Whatevs. There we go. This is gonna extrude out now. Sketch. Here. 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 Here to here. Associate midpoints because that'll be a lot easier. And this is going to be 3/8, I said. That's going to go straight down. Extrude 3/8. That goes into the play field like there. So you can see how that if the ball hits that, I mean it'll flex a little bit, but it's not going to be like a major problem per se. And this will also tell me when I go to bend this thing, since I bend this stuff by hand, the flex point needs to be right here. I'll be able to see, oh, it goes like right next to this thing. That's where the bend goes, and poof, done. Okay, now fillet 132 on the inside of these. Fillet 332 is on the outside of these. And then camphor 1/8 is on the corners of all these things, as well as the cut point here, or the embedded section here. Okay. So this is now, in theory, the guide for that section, right? And as I said, this uh, wire guide is going to need to get adjusted a little bit, which is fine. I mean, nothing wrong with that. And oh, right. This wire guide is what is it? It's a 1 1/4. It might need to be longer than that now. Let's go to in cut holes, device holes. Okay, this needs to not be that. This needs to be fixed. This needs to be there. This needs to not be fixed. Needs to come out here. Right there. So what length is this? 1.75, like almost exactly, which is awesome. Now the $1,000,000 question, however, is do I have 1 1/4 inch? Pull this way. I mean, I could just put another post right there. That wouldn't really affect anything. I don't know. I could just put a post there. Well, I'm trying to optimize those posts, aren't I? I don't want to put a black rubber post. Actually, this thing could bend down more. There's nothing wrong with that because this is the exit. So if this scoops around and reflects down, that might actually work better. So I'm gonna do that, and I'm gonna keep this set to 1.5. I'm gonna try something. No, that's not what I want. I want this to be fixed. I want this distance to, or this not to be fixed. This to be 1.5. And this is gonna come up a little bit there. Let's mate that together. All right, so this guide, let's bend this guide in a little bit more. Which, and I said I wasn't going to modify this, and now look at me modifying the thing, because of course I am. So this is no longer fixed, but this should be fixed. Bend you in like this. Now the ball's not going to get in there, and the rattle isn't going to be a problem. Yeah, I mean, that's a really tight hold to deal with. But it can be dealt with without much issue. Yeah, I think I'm okay with that. Okay. And next, I need to cut a hole here, or a slot right over here. Now this slot, this is going to be 3/8, and it's going to be the same radius as all these other slots. So let me just make sure I set this correctly. Now for this slot, I don't want it to bend in too much. Stop, stop, stop. I don't want it to. Can I please select the this line and this need to be parallel. Christ. Right. So I don't want this to flex in. So I'm going to pull this slot out, kind of right justify it a little bit. So if it bends, it's not going to bend much. And because the ball's slamming on this left side, it's not going to push to the right. You know, if the ball was slamming to the right side, then it could flex out and push the edges here. But, yeah. So just a little offset to the thing. Right, let's get rid of parallel. Let's fix that. Okay. So now that slot has a place to go. Or that cut has a place to go. I didn't line that slot up very well, did I? No, ow. No, I did not. Let's center it into there. That way these feet on the outside of the slot have a little bit of a better spot. And this also means I can actually justify it a little bit more in a second. Let's make this 3.5 or 0.35. So it's a little bit smaller. So it's, come on. And then this guy could come in ever so slightly more justified like that. All right, that'll be good. And now looking at this, yeah, the feet have a good place to sit. The slot fits right in the hole without any issues. There's enough flex space around the hole to get the thing in there, so it's not like an incredibly wicked tight fit. So yeah, that's all good. Okay, so now is the spinner problem over here. Um, so I don't think I can actually attach the spinner to this left side and have it look the way I really want it to look. I think I need to attach it to the right side. However, when I attach to the right side, I could still flip it. So, yeah, I could still flip it so these optos are on this left side here. because that can be hidden by scenery attached to this post pretty easily. Then the hole right here could be where the plug goes through. Not a lot of space for that hole now. There's plenty of space because it can be a slot right there. Hmm. If I just take this spinner and I flip it the other way, well, first off, it's not going to fit anymore. If I have that diagonal like, well, maybe that's diagonal like that. That actually might not be that bad. But then that's going to face more this left flipper. But the right flipper is still capable of spinning that. You know what? That might be okay because spinners don't need to be perfectly straight on. That might be okay. And I might change this to be 3/4 inch width and just move these holes a little bit more to the edges because that'll give me a larger through hole here for cabling. All right, yeah, I'm gonna experiment with something. Uh, so first off, let's save this. Secondly, let's open the spinner up separately. Where did I put this bracket? Oh, did I even put it in? No, I put in spinners because of course I did. All right, so seriously, are we really? Jesus Christ! I really hope Comcast isn't being a fucking pain in the ass constantly right now. Sorry, folks. I don't know what's going on with Comcast these days. It's been really bad these past couple weeks. All right. I want to sketch and we'll just have. All right. Now, what was I doing? Right. So I need to extrude up a little bit. Hang on a second. First off, why is this sketch not happy? Oh, fix that. And we should make this angle. Okay, that's fixed. And why? Oh, because of, yeah, all right, never mind. I'm just thinking out loud with a bunch of different things. All right, so let's take this. Let's go sketch. This needs to extrude up a little bit. I'll worry about the actual height in a few minutes. This will be 0.25. This will be 0.5 just for now. Again, I don't know exactly where this is going to be. I can always go back and change that. And features extrude. We'll make this 15/16 just for now. Again, I don't know the actual height of this yet. All right, so now I know it's on this one. I can't remember because Comcast kind of confused me. Sketch, evaluate. This was 1 and what? 1 and 13/16. Okay. And it needs to extrude out 1 and 13/16. Oh my God, really? Stop that. 5. I'm sorry, 1/16. And then extrude 1 and 13/16. Yeah. Then on this side, it comes back down. And then from here to here, from here here is 15/16. 1/16. Okay, so that's kind of the arc. Let's see where this aligns with the spinner. Right. Okay, so I did a decent guess, I guess. Okay, so obviously this needs to be a little higher. Let's go back to this first extrude. This needs to be 1 and 1/16. Yeah, there we go. And that comes all the way down to that. That's perfect for that spinner. And then these holes. I guess the easiest way to do it is on this hole and then do a through hole. So this hole is nope, 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 nope. What's this plane? Plane over there. This hole is, let's evaluate. 1/8 inch, right? 1/8 inch round, and it is 3/16 up. So on this side, I sketch circle and make sure it's 3/16 up from the center. Three 16, and this is 1/8. Root cut through all. Okay, now obviously this is not thick enough, so let's see what the thickness is supposed to be. So from here to here is 3/8. Okay. So that's easy enough to fix right here. The 3/8. And this can go down to 7/16. So it bumps over a little bit. So now that's in the right spot. Okay, so here's one difficulty, because see how these pads kind of come out the way they do here? That conflicts very much so with this left mounting height here. So instead of the pads coming out like that, it might need to be an armature that comes out and comes down, which is not as ideal. All right, let's add all the extra bends, the primary bends on this thing. Oh, sketch. No, I want features. Play 132 on the inside of these things. And 332 on the outside of these things. Okay. Yeah, now comes this stuff. Okay, so technically speaking, I can cut a hole here and bump something over. Um, I don't really like that idea. I honestly don't really like that idea. But what I am going to do is I am going to make a sketch that mimics where these holes are going to go. That way I know where it has to go on the bracket, and I might separate this out into a separate bracket that gets riveted onto the side. Then it's an easier thing to bend, number one, and get right. And number two, when it's mounted, it won't conflict with other sheet metal parts and features that I need to have. So that's my immediate thought right now. All right, so I'm actually going to delete this. Oh, let's exit this. I'm going to get rid of this opto spinner assembly now because it's getting in the way. I'm going to bring in the opto spinner part, and this is going to be mated to this side. Okay, stop. This, mate, this. Yeah. And then this parallel to this, but the other way. Pull this over here. And then this parallel to this. Okay. Yeah, so that, you can see that fits in pretty well. Plenty of space for that to be in there, to spin around, do its thing. It should not get bound by anything. It's just the opto mounting point that's a problem. Actually, it might not be a problem. Okay, let's figure out mounting points for this thing. So this comes out evaluate. This comes out 3/16 across, and it is 3/16 down. So it's 3/16 across and 3/16 down. And this one, okay, yeah, 3/16 across, 3/16 down. and 1/4 inch long. Edit component. Can't stop it. 3/16 across, 3/16 down. This is 1/4. This is 3/16. Is 3/16. Okay. Now this is from here, here. That is 7/16 across. Okay. And that is 1/16 and 1/8. 7/16, 1/16, and 1/8. That's 7/16. That's 1/16. And 1/8 from the edge. Okay, so that's that piece. So now I'm going to do that same extrusion down here. Where it's theoretically supposed to go. And then I'll figure out if I can do this on the same bracket, which I actually might be able to be honest. Okay, let's see how far down that is. Evaluate. From here to here is 3/4 inches. So this sketch from here to here, 0.75. Ooh, that goes way down there. I don't think I can do this. Oh, that goes way down there. I don't think I can do this. Yeah, because that's gonna affect the integrity of this piece. Um, could I? Well, that would make it really complex. And I kind of want this just to be a regular micro switch. So as of right now, it's looking like the spinner needs to be a separate assembly that's riveted on to this because of how this opto needs to be placed. Unless, yeah, because the cabling comes out of the opto back. Well, I can loop it like that, right? That would make it more consistent. How would that? Oh no, that wouldn't work though because it's still digging into the like when the sheet metal is forming, it's still digging into that. Oh wait, I got an idea. Yeah, I got an idea. What if I make a 3D printed plastic part that the opto attaches to, and there's a singular bracket over here behind, you know, that kind of sticks up on a wall here that the plastic part screws into, that then perfectly aligns with the thing. That actually might work okay. I think that's how I'll do it. I think I'm going to make a 3D printed part that screws onto the side of this piece of sheet metal that will have the opto assembly screw onto it from the front to align with, you know, this spinner thing here with the little spinner actuator or piece, and then it's going to screw into the side of the sheet metal. So the sheet metal screws go in here, the sensors here, and or the plastic piece is here, and the sensors in the front, and that'll still allow the cabling to go through the back. So I'm gonna do that. I'm gonna do that because this is just not gonna work. This is gonna cause too much. This is gonna be a pain in the ass to bend properly. For me personally to bend properly, and it's going to be a pain in the ass. Well, and it's going to add too little shielding and rigidity to this section over there. All right, so I'm going to get rid of this. Because this way I know kind of where this needs to be, and I can line everything up. Um, and in fact, yeah, no, I'm gonna do that. So this is how I know where things need to line up, and I'm gonna make the plastic piece come out, bolt onto this, and bolt right down there. Which means I can continue to extrude this out more as a second operation. And this is going to extrude out an extra um, 3/8. Then I can put a screw right there. Right down the line here. perpendicular. This is already perpendicular. Hole there, hole there. These are going to be 1/8 holes. This is going to be 1 inch apart is fine for the mounting. And that also aligns with these screws too, which makes life nice. Okay. It's going to be 3/16. No, 1/8. There, 1/8 from there. Okay. So now this part will be manufacturable. Oh, I did want to extrude. Oops. I want to cut. Okay, and now so once I get the actual plastic part made, I am going to get rid of these other pieces and I am going to thicken this thing up a little bit, which will involve probably going right from this edge down a little bit more. That way when I screw these pieces in, I really want them to be in the right spot. I don't need to make the whole thing flat, but I do need more rigidity because this is a flap that can just kind of wiggle around over the place, which will um, get out of alignment with the sensor really quickly. So I don't want that. And what I'm also going to do on this side, just for funsies, so I know where bends need to go, is I'm going to fatten out these edges a little bit. And it's not really needed. It's going to be more aesthetic-ish, but it'll tell me where this bend and this bend need to be when I go to manually bend it, and then add rigidity to this thing here. Okay. All right, so let's exit this component. Exit isolate. Because this now is fitting. Yeah, I think I'm okay with that because that's gonna spin and is that gonna hit this thing? Well, let's find out, shall we? So this spinner piece is mated horizontally. Let's suppress that for a second and let's rotate this like there. Is that hitting? No, it's not going to hit. I mean, barely not going to hit, but it's not going to hit. Yeah, I mean, barely not going to hit, but it's not going to hit. And actually, it'll be better if I pull it down and tickle. Yeah, if I pull this down ever so slightly, then that'll give it more space. And based on where this target is anyways, come on, really? Can I rotate, please? Yeah, based on where that target is, I can probably pull this down a little bit. Oh, that's 6/16. And so that pulled it down a little bit. That'll give it the extra space it needs on that rotation. And when this table is in on the actual on its actual 6.5 degree slant, this end is gonna flip up a little bit more, which I can technically mimic, which I might want to do. So 6 degrees the other way. No, this way. So this is how it's actually going to sit because of gravity. Right? And so that's not in front of this thing. So if the ball hits here, it's not going to clip the side of this really. That's okay. All right, I'm going to again rotate this like 45 degrees the other way. '60. Oh yeah, there's plenty of space now. Oh yeah, look at that. There's tons of space over in that corner. So it's full 90. I mean, it doesn't look like there's space if you look straight and kind of straight downish on it. Oh, even straight down, there's plenty of space. So by the time it curves around, yeah, see, yeah. So yeah, there's plenty of space on here. All right, let's set it back to 6. Yeah, there's plenty of space now. Okay, good, good, good. All right, let's make that plastic piece. So this plastic piece needs to, and I don't need this anymore. New part, um, front. This is the important section. So this has those two 16th inch holes. That are um, there, there. This was what, 3/16 from the edge, I think. These should be um, equal and collinear. These should be equal. This and this both need to be horizontal. The distance between these holes is not something I measured, so I really should measure that. This was 2.5. This was 3/16. This was 7/8 from the edge. I think, right? And then I think this is like an inch apart. Let's now take this midpoint. We get rid of that. Let's combine, put that midpoint there. All right, what is this really? So that's 7/16 across, 1/8 over. And the distance between these two center points is exactly 1 inch. So if that's 7/16 from there, then that's 6/16 in reality across with 1/8 inch. Okay. So this in reality is 6/16. Come on. Come on. 6/16. This is 1/8. So that's where those mount technically against the edge there. So now and extrude 1/8. Okay, so now I want to connect this side here. And this side. Well, this section actually does need to come out quite a bit more. Sketch. So I can probably connect on this. What does the cabling actually look like? I need to figure out what the cabling looks like. Yeah. So that is are there good images of this somewhere? Yes, I saved something somewhere. Okay, so this is the Opto. Let's see if there's some good drawings of this thing. And in fact, there is. There's a really good drawing. Yeah, so the distance between that is 1 inch, plus or minus. Oh, wow. Yeah, there's definitely a really good drawing of this, huh? So I just need this to be able to slide in to a spot. So actually, before I make this part, I'm going to move this out in the corner. Before I work on this part, how about I make that actual spinner part? New part. So this is going to be Opto. So this needs to be a slot. This needs to be 1 inch between these points. This needs to be a radius of... Doesn't tell me the radius. Oh, yeah, no. A quarter. And the holes are 1/8. Yeah, that's looking about right. And that is 0.1. And on the front, we got 2 bump outs. Centered midpoint. These are both equal. And they are 3/8 across. And 0.75. Yeah. Can you give me the actual thickness instead of the stupid? No. All right. And then from here it's 0.735. 0.75. Like that. And these are... Oh, you're telling me from the 0.42. 42. But it's offset from surface. It's gonna be this surface. It's gonna be 0.42. Yeah. All right, and then these things sketch. So this and this convert. Sketch, please. Thank you. Now convert this and convert this. Good. This is extruded like... Oh, that's wrong. That's wrong. That's wrong. Nope. Sketch. This one is... So let's convert. This is cut. 0.08. Oh, it's not. Oh, that's a fine. Offset from surface. Point oh, there we go. Okay, so that's that. All right, so now let's go to the back. This has... That doesn't help me. Oh, is that how that? No, that's 0.6. Oh. Okay, 0.64. All right, 0.64. Because these two little posty thingies, horizontal, horizontal, and they're equal. Horizontal. And this is midpoint. Then the distance across there. All right, so that's 0.19. 0.19. This distance, it doesn't say the thickness of this thing. Great. That's the one dimension it doesn't tell me. All right, well, I'm going to say it's 0.1 or 0.1. I'm going to say it's 1/8 because I have no idea. And the distance from here to here is 0.65. What's the what is 3 or what is 5/8? Too small. 5/8 11/16. Yeah, I'm gonna say 11/16 on this just so there's an extra little bit of space just in case. And then those bump out 0.19. And then in the middle here, come on. There's this thing. That an arc. Let's do a 3-point arc. And this is that distance is 0.04. Get off of that. 0.04. And then, okay, that goes all the way up to the edge. Extrude. Are you going to tell me the thickness of that thing? No. I'm going to eyeball it. It's just a support thing. All right, and it's going to be 132 on both sides. Okay, so this is effectively the opto bracket. Now let's color this something fun. There's color, plastic, low gloss. dark gray. Now, the emitter, let's color the emitter. Color the emitter blue. I mean, not that it really matters, but that's the emitter side. Oh, that's got a little hole in it. Sketch. We'll make this 132. We'll throw it kind of like here. Features extrude cut 132. Yeah, so now that's a little more accurate to the drawing, because if you look at the drawing here, it has built-in ENS and it's got a tiny little dot there. So yeah, I think this is pretty accurate for what I care about. And this part number is the opposite blah blah blah, blah. Files save as would be in my parts library. Okay. So now that I have this, let's add a component, add a component. All right, file save. All right, I'm going to do something a little different. I'm going to create save all. I'm going to create a new assembly. I need to start getting ready to go. New assembly. Now, because this is getting semi-complex for the guide, plastic metal guide, right orbit inner. Nope, that's not what I want. I want metal guide spinner left. Yeah, because this is getting somewhat complex. I want to make sure that it's all like in the right spot, and it's going to be easier to just do it as a subassembly. Because when I make this, it's probably going to be a subassembly than I just plop in anyways. And now I need the spinner. I also need the... Where the fuck did it go? Right, electronics, opto emitter. And what I can do with this... Oh, I see. Oh, because they attach the... Oh, yeah, that actually works in my favor, actually. All right, so if I mate with this and mate with this and mate this side with this. So now that's in the exact right spot it needs to be. And I can hide that. Can I move this around still? No. Okay, so this is going to be fixed for sure right there. This, I'm going to mate with this. This, I'm going to mate parallel with this. This is going to be actually 6 degrees. And then this, I'm going to mate with this. And that's going to be flipped. Oh, perfect. And then this. Oh, I can do an offset on that actually. Give me an offset actually of got it straight on. 1, 25-inch. 7 millimeter. 7 millimeter is perfectly in there. Yeah, you can see where this, how this is sitting. So now I need to fix this off, this rotation. Flip dimension. Flip that. Flip dimension. Yeah. So by default, you can see by default this is outside of the sensor, but then it'll click into the sensor when it spins. So this will now all work correctly. That's in the right spot. Okay. Save this as spinner left. I'll make an assembly directory. Metal guide, spinner loop left, sub, sem. Okay. So that's that. So now with this is actually going to be a little easier because this part here that I was mucking around with, I now have actual positions of things here that I can figure out like what everything needs to do with this. And you can see because of the size of this thing and the size of the connector that it's going to have, it's going to be in shit. All right, well here's an issue I didn't think about. How am I going to screw down? How am I going to screw down there? I'm not. So in fact, this footprint needs to change. I can get to this one, but I can't get to this. So this footprint should change and go straight up. So that's something you don't know until you start adding all the components. That would be a bit of pain in the ass, right? So I mean, another option is if I pull that up, then I could separate these out. So I could pull this down a little bit. I could pull this other one up. Well, but there's cables and all kinds of other shit, so I can't do that. So no. In fact, this needs to move over. So let's go to what sketch is it? This sketch. Okay, so things need to change here a little bit. This can't be equal that. But this can be equal fine. Next. This can't be perpendicular. And this can't be perpendicular. This should still be 1. But this over here, why are you giving me... Oh, because that's midpoint. So this can't be midpoint there anymore. Okay. Yeah, because this needs to come out like there. Right? Um, so this from here to here is still fine. This from here, come on, do that, thank you. This from here to here is still fine. And these can still be equal. So that's still fine. This needs to be over here where a screwdriver can get to it. Actually, over down here where a screwdriver can get to it. So this shouldn't be perpendicular either. This should come in like this. Let's see what's kind of going on here. So this is still gonna like give the the footprint rigidity that I want with the slam here. But now I have a place that I can actually put screws in. Right? I can actually get the screwdriver in there. Now the other thing I am gonna do, because I'm thinking about it, is in this this distance here, this 1/8, I am going to change it to 1/16. That'll make this a little more accessible, which in turn pulls this more like there. Okay? So that's what the new mounting point looks like. I mean, it's not as pretty as it used to be, but really, I need it to be functional. And there's not a lot of metal here holding this thing, but that's fine. The point of this isn't to bind that down. That's what this screw is for, and that's what this other screw is for, right? The point of this is to help prevent the ball from slamming and malforming the edge of this thing here when the ball hits right in this spot. That's what this... So this is a shear force. This right here is a shear force going to the left. This is right here is a bind force going down, if that makes sense. So this pad here, this in cut over here, let's this in a better view. This in cut right here that goes into the playfield, that's a shear force for when the ball slams into the side, and this screw is a shear force for when the ball slams into the side. This screw is the bind force binding it onto the playfield, and this screw right here is a bind force binding it in place onto the playfield. I hope that makes sense. Okay, so now that that's all taken care of, I don't know if I have time to make this other part that's gonna mount right here, but certainly what I can do now, because I have this in the spot that it needs to be, I can do a couple of those other little niggly things I said I wanted to do. So on this side, well, let's edit component. Well, this needs to be widened. This whole sketch here can effectively go away, and that's gonna make something complain. I'll deal with that in a minute. This this extrusion right here can be thickened, because now I want this not to be like that. This midpoint should stay fixed here. But this is going to attach to that, like there. Okay. So now I know where this bend needs to go, and then this flap is stronger than it previously was. Next, this section here, other side, I'm going to widen here. You know, just a tickle. On both sides. These are going to be equal. These are going to be equal. This I want it to be 1/16 is fine. 1/8 is better. From here to here is going to be 1/8. Screwed. Up to surface. This surface. Okay, so now this serves two purposes. Purpose one, I mean, it adds a little more rigidity to that, right? And that might be too heavy for this assembly now, but it adds a little more rigidity to this flap. But I now know exactly where this bend needs to go and where this bend needs to go, like perfectly. And yeah, I am going to change this. I don't like that. 1/16. 32. Yeah, that's better. So now that tells me exactly where this needs to be. Okay. I don't want to put too much weight on this side because of the because of what this metal does. It's probably fine, but anyways, I know where this bend needs to go on both sides now. This bottom section, I can put a couple fillets. Here's fillet 1/16. And actually, just for funsies, I'll put that same 1/8 fillet on this side. Not on that side. Okay, so this is essentially going to be the bracket. I kind of want this not to be so close to the edge. 3/16. No. This is 3/16. Which means this extrusion should be 7/16 just to bump it out a little bit more. Make sure everything's kind of where they need to be. I don't want screw holes to conflict with each other. So what I'll probably end up doing is I'll pull this screw hole down and pull this screw hole up. That way I can have a screw going in that way, and then screws going in without conflict. Okay. And the last thing I want to do is make sure that this, which now that this probably needs to be a fillet, but I'm going to make sure that this now still fits in the correct spot in pumpkin. Pumpkin King. This. Because officially, this is gone. This is gone. And officially, this is added. 8. Here's my bottom. Where's my assembly bottom? See, this is a problem now too, which so I'm gonna have to monkey around with this section to make sure things bind properly and make sure you can get the screwdriver here because this don't rotate that way. You know, getting the screwdriver in behind here is not going to be a fun time. And I can't pull this out anymore, really. And I don't want to add a flap coming on. Yeah, that'll be a problem for future me to figure out. Maybe I'll make a metal guide with a stud here and a flap on this side, or small flap or something on this side. I don't know. It's this section here. Like obviously this screw is fine, and I can always move this a little bit. And yeah, I can't put another screw over here because of the plastic assembly is all right here, and that'll hit with it. Yeah, so it's there's still some questions with this. However, that aside, I mean this is in the right spot, the way it's supposed to be. Everything kind of matches up. The pumpkin now has a hell of a lot more space because I don't have all that opto horse malarkey to deal with. Put this into guides. Uh, anyways, this was a lot of good decisions that were made and figured out. Device holes. I can hide that now. I'll deal with dimples another time. I need to start getting ready to go to the Rhode Island finals. But yeah, okay, so this is kind of the assembly and brackets that I'm thinking about so far. Yeah, I really would like to add that foot. And then, of course, there needs to be a hole right here, actually, while I'm thinking about it. Ow. There should be a slot. No, no, no. 3/8 and then be 8. Yeah, I mean this slot can fit like right over here for things to kind of come up and into. That should be plenty big enough for any cabling that this needs to go down and into, and any other stuff that comes up into this area. Now, what about GI for this thing? Well, I can probably have a spotlight, you know, or I mean, I have a spot right here. I could make a custom 3D printed thing that can hold an LED and shine a certain way. It can pop up through this hole right over here. I mean, I can fit GI there. I'm not overly concerned about that. I'm more concerned about the size of the plug for this cable to be able to get into the bottom. And to be quite frank, there's not going to be a ton of like in playfield GI. I'm going to have like the standard GI around the flippers and slingshots, but then most of the lighting is going to come from sidewalls shining down in, and I'm going to have a couple random GI spots in some really dark areas just to give self luminance effects rather than visual clarity of the area. Most of the visual clarity is going to come from the top, and the bottom is just going to be self illumination type of effects to add, glow and other things. All right, yeah. So with this, there's so much more space for the pumpkin assembly and other things because I don't have all of this junk on the right side anymore. And that's still aligned perfectly fine. You can shoot it with both flippers. It's not going to get in the way of the targets or anything. So yeah, I think this worked out pretty well. And technically speaking, I could, in theory, get a stern spinner. So like this stern spinner, this is like a stern opto spinner or some such. If I get this is even thinner, and I could make that bracket down there thinner. It if I really am worried about like horizontal space and clashing with things. But I don't think that's a problem, and this will block this pretty nicely. I can put like a nice vine shape on there, and it'll work out pretty well. So, all right, I think that's the stream today. I'm sorry about the internet problems that I had a little bit about an hour ago. Got a lot of good things done. Really, just this section, but this was a particular section or a finicky section to kind of figure out. Still need to figure out where to put this binding point here, but I don't think that'll be too bad. Like I said, this is just a shear point, so maybe I can stick something else into the wood so it has like an L that mounts in the wood to prevent shear forces. I don't know, but I can figure that out next time. Yeah, so next stream I'm gonna finish up everything that needs to happen over here. So this other little bracket, the questions around there, figure out how the plastic is gonna line up in this area here with the ramp and where the pumpkin actually needs to go. And that'll probably be the lion's share of the stream. Then I'm gonna finally start getting back to this right section, because this really needs to be the definition of this really needs to be done. The importance of this section though is I needed to know where the dimples are and I needed to know where all the holes are. if I'm going to cut another playfield, I don't necessarily need to know what this plastic ramp is going to look like on this right side necessarily, but I do need to know where all these dimples go, right? I do need to know where this through hole goes or where some of these other points lie. And we're now more so at the point where we know this. Oh, yeah. Yeah, and this is cutting into the pumpkin, obviously. But remember, this ramp bends up, and it'll be underneath the curvature of the pumpkin in this area, very much so. So it really won't clash. It's just I didn't model it so it bends down. All right. Well, I hope you all enjoyed the stream, and yeah, I hope you all enjoyed the stream, and I'll see you next time. Bye.